Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 120, determine the product of inertia of the composite area with respect to the x and y axis. Here is the given figure. Notice that the two figures are symmetric with respect to the centroidal axis. So if we apply parallel axis theorem, then the centroidal moment of inertia would be 0. So Ixy with respect to the centroid. Ixy equals moment of inertia of this square with respect to the centroid, which is 0, plus area, which is 4 square. Barred x is 2, barred y is also 2. Then minus the moment of inertia of this circle, which is with respect to the centroid 0. Then area pi 1.5 square, barred x is 2, barred y is also 2. So Ixy equals I barred xy plus area barred x barred y. That's our guide. So for the square, Ixy equals 0 plus 4 square times 2 times 2. Then minus for the circle with respect to the centroid 0. Then plus pi 1.5 square barred x 2 barred y is also 2. So using your calculator, Ixy equals 35.73 inches to the fourth. Level 121, determine the product of inertia of each of the four areas about the xy axis. So take note that each of these areas has centroidal axis, has symmetric axis. At this one, for these three, all have symmetric axis both. So with respect to the centroid 0, if we apply parallel axis theorem, then the only part of the term which has moment of inertia about the xy axis would be that area barred x barred y. Same is true with this semicircle. So for part A, the moment of inertia with respect to the centroid is 0, then area 80 by 50, barred x 60, barred y 40. So Ixy equals I barred xy plus area barred x barred y. That's our guide. So for Ixya, it is equal to 0 with respect to the centroid plus 80 times 50 area barred x 60 barred y positive 40 also. So Ixy of the figure in A is 9.6 times 10 to the 6 millimeter to the fourth. For part B, Ixy with respect to the centroid is 0, then plus area pi 25 square barred x negative 60 barred y 40. So Ixy of the figure in part B is negative 4.712 times 10 to the 6 millimeters to the fourth. Then for part 3 also with symmetric axis, so 0 with respect to the centroid, then area 50 by 80, barred x positive 60, barred y negative 40. So Ixy of part C is 0 plus 50 times 80, barred x negative 60, barred y negative 40. So Ixy of part C is positive 9.6 times 10 to the 6 millimeters to the fourth. Then in part D, with respect to the centroid 0, so we need to locate the centroid from the diameter. It is 4 times r over 3 pi. 4 times 25 divided by 3 pi is equal to 10.61 mm. So therefore, the total distance of the point below the x-axis is 50.61 and it is negative. So Ixyd is equal to 0 plus area pi 25 square over 2 times barred x positive 60 barred y negative 50.61. So Ixy of part D is negative 2.981 times 10 to the 6 millimeters to the fourth. Level 122, determine the product of inertia with respect to the x and y axis for the quarter circular thin ring where the thickness is very much lesser than r by integration. So here's the given figure, and let's have a sector element. That's our differential strip, differential element, which is this. So the radius is r, the angle from the positive x-axis counterclockwise is theta. The radius is big R, big R. The angle here is differential theta, therefore the arc length here is r times differential theta. The differential area therefore is r times differential theta, arc length times the thickness of the wire. And the distance of this point, this element from the y-axis by trigonometry is hypotenuse radius cosine of theta as labeled. Then the vertical distance of that element from the x-axis is hypotenuse radius times sine of theta. So this is the y, r sine theta, the x is r cosine theta. And remember, Ixy equals integral of xy differential area, where x is r cosine theta, y is r sine theta, and differential area is r d theta times the thickness, or thickness times r d theta. So Ixy equals integral of quantity r cosine theta, limits from 0 to pi over 2, the variable is theta. Y is r sine theta, and differential area is thickness of the ring times r d theta, the length of this differential arc. Factoring out r cubed t, then we have r cubed t integral from 0 to pi over 2 of sine theta, quantity cosine theta d theta. So this is in the form sine theta, which is u, and the differential of sine theta is cosine theta d theta. So this is in the form u du. The integral is u squared over 2. So Ixy equals r cubed t, quantity sine squared theta over 2 from 0 to pi over 2. And we note that sine of pi over 2 is 1 and sine of 0 is 0. So Ixy equals r cubed t over 2, quantity 1 square, sine square of pi over 2, 1 square, minus 0 square. So this is just 1. Therefore, Ixy is r cubed t over 2. Then level 1, 2, 3, the final problem for this video. Using the parallel axis theorem, determine the product of inertia of the area shown with respect to the centroidal x and y axis. So we only consider these two areas, the area, rectangular area between these two areas is symmetric with respect to the centroidal x-axis. So its area has a value with respect to the centroid 0, its area 0, but barred x and barred y 0 also for this area. So we only account for these two rectangles. The area is 10 mm by 80 mm, so 800 each for our solution. So we divide the rectangles into this manner. We ignore this center rectangle because the moment of inertia with respect to the xy axis is 0, because x and y axis are the axis of this element, and it is 0 also. Barred x is 0, barred y is 0 also for this rectangle. So the area is 800, this is also 800. The horizontal distance of the centroid from the y-axis is the same for the two, so I just label for the left, but this is treated negative while the barred x of the right rectangle is positive. So 100 divided by 2 is 50, plus half of 10, 5, so 55. So that's the centroid, that's negative 55. And its y coordinate is positive, which is the same coordinate here. And I'll just label this right part. It is negative here, but positive here. So since half of 80 is 40, and this is already 20, so the distance from this point to that axis is 20, therefore this is 20 mm below the x-axis, and that centroid is 20 mm above the x-axis. So both are symmetric with respect to the axis, so the centroidal moment of inertia, this term is 0. So we only consider this second term. So Ixy, therefore, let's begin with this left rectangle, is 0 plus area 800, then barred x negative 55, barred y 20. For this area here, with respect to the centroid 0, area 800, barred x positive 55, barred y negative 20. Solving for Ixy equals negative 1.760 times 10 to the 6 millimeters to the fourth.